So in this part, they're saying carbon can react with a limited supply of oxygen to form carbon monoxide, which can negatively affect human health. Part 1, write a balanced chemical equation, including state symbols, to show the formation of carbon monoxide. Plus oxygen gas, which will give you carbon monoxide, which is also a gas. So this needs to be balanced. There's 2 oxygens there, 1 carbon, 1 oxygen on this end and 1 carbon. The oxygens need to balance, so we put a 2 in front here. Now that the carbon becomes 2, we need to balance the carbon on this end, so we put a 2. Good?
Yeah.
Part 2, state 2 effects of carbon monoxide inhalation on the human body. All right, so carbon monoxide inhalation causes carbon monoxide poisoning where it replaces the oxygen in the red blood cells, causing dizziness, fatigue, loss of consciousness, or even death. So if you didn't know, now you know. All right, so the carbon monoxide actually replaces the oxygen in the red blood cells. Okay, so now that you have low oxygen in you, it's going to cause dizziness, fatigue, loss of consciousness, or even death. Jamal wants to prepare and collect a sample of carbon dioxide gas in the laboratory using calcium carbonate. Part 1, write a balanced chemical equation, including state symbols, for the laboratory preparation of carbon dioxide gas from calcium carbonate. Okay, so you had 1 reagent correct, which is CaCO3, calcium carbonate. But it's reacted with the acid HCl. So this is the reaction. And what are the products of this reaction?
Carbon dioxide and water.
Alone?
And calcium.
Calcium chloride. That's a salt. Remember, it's the metal that kicks off the hydrogen ion from the acid.
Yeah.
So it's calcium chloride, the salt, plus H2O liquid, plus carbon dioxide. So that's the balanced chemical equation there already. Part 2, draw a clearly labeled diagram to show the arrangement of the apparatus and materials that could be used in the laboratory to prepare and collect the carbon dioxide gas. Part 3, state 1 use of carbon dioxide as it relates to the beverage industry.
Carbonated drinks.
Correct. So it's used in the production of carbonated or fizzy drinks. Part C. A student, while investigating the reactions of chlorine, bubbles chlorine gas into an aqueous solution of potassium iodide and deduces that the potassium iodide was oxidized because a change in color occurred. Part 1. Write a balanced chemical ionic equation for the reaction that is responsible for the color change. Your ionic equation should look like this. Two iodide ions. Cl2 gas. Cl2, Cl minus aqueous. I. Good. Part 2. Describe the color change that the student observed. So what color change do you think occurred? In your reaction, there would be no colors, so it would be colorless to
Brown.
yes, iodine and solution is brown. All right, so part D, sulfur is an element that is bright yellow in color and burns in air to give an acidic gas with a choking smell. Write a balanced chemical equation with state symbols for the burning of sulfur in air. Do you know that equation?
Sulfur plus O2. I'll get sulfur oxide.
Sulfur dioxide.
And
So that's the gas that's formed.
yeah.
Right? They said it gives an acidic gas with a choking smell. State one use of sulfur. Well, sulfur can be used in the manufacture of sulfuric acid, gunpowder, matches. Can be used in fungicides, pesticides, and vulcanized rubber. So those are some uses, but they just want one use. So let's put it is used in the manufacture of gunpowder. Sulfur. Part 3, sulfur is in the same group as oxygen and so undergoes similar reactions. Write a balanced chemical equation with state symbols for the reaction of magnesium with sulfur. So they tell us that sulfur is in the same group as oxygen. So it will react similarly as oxygen. And they want to know how magnesium is going to react with sulfur. So to know that, we'll need to understand or remember how magnesium reacts with oxygen. You remember that reaction? When magnesium reacts with oxygen, what is formed?
Magnesium dioxide.
Magnesium oxide.
Oxide, yeah.
Right. So it's not two oxygens, it's just one. In this case now, so we're using sulfur, well, magnesium, metal, plus sulfur, going to give us MgS, which is magnesium sulfide. So as you notice, this reaction is already balanced.
Yeah.